In this lesson, we will study how to solve quadratic equations by factoring. Let's first start with a definition for a quadratic equation. A quadratic equation is an equation of the following form. ax squared plus bx plus c is equal to 0, where a, b, and c are real numbers. Now a must not be 0 because if a is 0, then this whole first term would be 0, and then you would no longer have a second degree term, and you'll be left with a linear equation, a degree 1 equation. So let a, b, and c be any real number you want, but a must not be 0. All right, so in order to solve these kinds of equations by factoring, we're going to study a rule that's called the principle of zero products. The principle of zero products. This is what it says. The principle of zero products says that if any product is 0, then a factor must be 0. In other words, if a times b is equal to 0, then that implies, this double arrow means implies, that either a is 0 or b is 0. Let me actually write the word or in the middle here, or b is 0. In other words, one of these factors must be 0 in order for the product to be 0. Here's our first example, and the instructions say to solve for x. Now, there's a couple things I want you to notice about this equation. Number one, it's factored already for you. That's great news. Second thing I want you to notice is that this equation is set equal to 0. That's also really great news. We can use the principle of zero products that says if this factor times this factor is equal to 0, that means one of these factors must be 0. So what we can do is we can say this statement is true only if this factor is 0 or this factor is 0. So you set each factor equal to 0, and then you can solve each statement. So this one says either x is negative 3 or x is equal to 2. And we're done. That's it. Okay? So the whole idea is if you can have a quadratic equation that's factored and set equal to 0, then just set each factor equal to 0 and solve. Let's look at another example. All right, here's our second example. Let's solve for x. Again, notice that this equation is already factored. Awesome news. And it's also set equal to 0. I would actually invite you to pause the lesson right here and try this one on your own. It's very similar to the previous example. So go ahead and pause the lesson here and try solving for x. All right, so I got 7 or negative 1/5 that has solutions. I set each factor equal to 0 and solve. This one I just had to add 7 to the right and I was done. But this factor, or this equation rather, I had to subtract 1 and then divide by 5. So we have two solutions, x is equal to 7 or x is equal to negative 1/5. All right, I hope that was smooth for you. Let's look at another example now. X times 2x minus 9 is equal to 0. Now, it must be clear to us that there are two factors. The first factor is a monomial factor, right? And the next one is a binomial factor. We can still use the the principle of zero products and say that either the first factor is 0 or the second factor is 0. Okay? Now, this one's already done, right? X is 0. But this one needs a little work. We need to add 9 to the right and then divide by 2. So this solution over here is 9/2. Okay, so either these two solutions will satisfy this equation. Okay, and you can prove it. You can plug in x equal to 0 and show that you get 0 as a product. Okay, you can also plug in 9/2 and confirm that you get 0 as a product. All right, you can always do that for all of these. Okay, let's look at another example. All right, here we go. Example 4, x squared plus 5x plus 6 is 0. Now, notice that this equation is not factored. But there's great news. You and I are really comfortable, I hope, with factoring by now. And so let's go ahead and factor ourselves, since this is not factored for us, and then we can use the principle of zero products. All right, so notice the GCF is 1, so we can go ahead and skip that step of factoring out the GCF. Also notice the leading coefficient is 1. Because the leading coefficient is 1, I'm going to go ahead and start setting up my factorization like this. Don't forget that this is an equation set equal to 0, so put equal to 0. And the factorization must start with x and x, because x times x will get us x squared. Both of the signs must be positive because the last term is positive and the middle coefficient is positive. And I'm looking for factors of 6 that add to 5, so that would be 3 and 2. Now that this is factored, I just set each of my factors equal to 0 and solve. This is the principle of zero products. So I get two solutions, x is equal to -3 or x is equal to -2. Cool, and we are done. So if it's not factored, then all you have to do is factor it yourself, and then you can use the principle of zero products. All right, we have x squared minus 8x is equal to -16. Not only is this equation not factored for us, and we're going to have to do it ourselves, but it's not set equal to 0. You always, most of the time, you're going to want your quadratic equation set equal to 0. So let's go ahead and move this -16 over to the left, and we can do that by adding 16 to both sides. When we add 16 to both sides, we get x squared minus 8x plus 16 is equal to 0. Notice that the leading coefficient is +1. Also notice that the GCF is 1. So we're going to go ahead and jump into our factorization now. In order to get x squared, we must have x and x. Notice that the last term is positive, which means the signs are the same. The middle coefficient is negative, so they both must be negative. I'm looking for factors of +16 that add to -8. That would be -4 and -4. -4 times -4 is +16, and -4 plus -4 is -8. All right, so we're going to set each factor equal to 0 and solve. This is the principle of zero products. But this is a redundant equation. You're going to get the same thing twice. So it's silly and unnecessary to do the same equation twice, right? And so I'm only going to do one. I'm going to say x is equal to 4. Now this is the one and only solution. The one and only solution. If you solve this one, you're just going to get x equal to 4 again, right? So the one and only solution is 4. Okay? Now for our notes purposes, I just wrote duplicate. Like this equation is a duplicate of this one, so it's unnecessary to solve this one, when we've already solved it. Okay? All right, next example. All right, we have x squared plus 5x is equal to 0. Now, I like the fact that it's set equal to 0. That's good. Let's start factoring it. Now, the GCF here is x, so let's go ahead and factor out the x, and that would leave us with x plus 5 as a result. And now that this is factored, and it is completely factored, we can set each of these factors equal to 0 and solve. So we're getting two solutions here, either x equal to 0 or x is equal to -5, right? So 0 squared plus 5 times 0 is equal to 0. Or -5 squared plus 5 times -5 will also be 0. So either of these two solutions, either of these two numbers or values will satisfy this equation. All right, 4x squared is equal to 25. Now, what are you thinking here? What should we do first? I hope you thought, let's subtract 25 from both sides. Let's get this equation set equal to 0. All right, so now we have it equal to 0, and we want to factor. Notice the GCF is 1, so we can skip that step. But what do you notice here? What do we have? It's a binomial, and it's a difference. Is it a difference of 2 cubes? No, because 25 is not a perfect cube, neither is 4. Is it a difference of two squares? I hope you said yes. And a difference of two squares always factors as a product of two binomials. One factor will be plus and the other one will be minus. In order to get 4x squared, you're going to have to square 2x. So I'm going to put 2x here and here. In order to get 25, you're going to have to square the number 5. So I'll put 5 here and 5 here. All right, cool deal. That was factoring a difference of two squares. You can go ahead and finish this problem out. Go ahead and pause the video, please, and finish this problem. Okay, I hope you agree with me that one solution is negative 5 halves and the other one is positive 5 halves. Good job, everybody. All right, we have a trinomial here. It's negative 5x squared plus 2x plus 3 is equal to 0. Now, you know what's not convenient is the leading coefficient is negative. So I want to take care of that. And the way I can do that is by factoring out a negative 1. That would leave me with 5x squared minus 2x minus 3 is equal to 0. Okay? All right, so what I'm going to try to do is factor the trinomial that's inside here. And we learned how to do this by using the AC method. And so in this example, a times c would be equal to 5 times negative 3. Now remember, I'm looking at the trinomial in here. This would be negative 15. And so what you and I want are factors of negative 15 that sum to negative 2. That would be negative 5 and positive 3, right? Negative 5 times positive 3 is negative 15, and negative 5 plus 3 is negative 2. So I'm going to split this middle term into two terms whose coefficients are negative 5 and 3 with the same variable part. So here it is, 5x squared, and then I'm going to have negative 5x plus 3x, and then don't forget to bring down the minus 3. And don't forget, this is all set equal to 0. So this term here turned into these two. And now we can factor by grouping. All right, let's do it. So you got a negative on the outside. And how about 5x squared minus 5x? Maybe. Plus, and then 3x minus 3. Don't forget, this is all equal to 0. Okay. This would be a great point at which you can pause the video and finish this problem out for yourself. All right, how did you do with your factorization? I got negative times x minus 1 times 5x plus 3 is equal to 0. So what I'm going to do now is I'm going to set each factor equal to 0. Now, I'm not going to set this factor equal to 0. I guess I could. Let me show you how silly it would be. It would be negative 1 is equal to 0. That's what that negative is out there. X minus 1 is 0, or 5x plus 3 is equal to 0. Now, this here is silly because negative 1 is not equal to 0. Now, we all know that's not true. So I just kind of toss that aside or away. And I'm either getting x is 1 or, after subtracting 3 and then dividing by 5, negative 3/5. Two solutions, 1 or negative 3/5. Good job, you guys. All right, this last example here will wrap up the lesson for us, okay? Now notice, although this is factored, it is not set equal to 0. It's not set equal to 0. So that's a big problem here. We need this to be a 0. So what I'm going to do is I am going to subtract 5 from both sides, okay? That would leave me with x plus 2 times x minus 2, and then minus 5 is now equal to 0. So that's really good news. But Notice that the left-hand side is not factored. It's actually a difference, right, of two different terms. So what I'm going to have to do is I'm going to undo this factorization here and then combine like terms and then factor. Okay, I have to undo this factorization. So I'm going to go ahead and multiply. Some people call this foiling. Okay, so you would get x squared minus 2x plus 2x minus 4, and then don't forget you have a minus 5 is equal to 0. Notice that these two terms are opposite, so they cancel. And also notice, please, that these two terms here are like terms that we can combine. And so we end up with x squared minus 9 is equal to 0. Oh, we have a difference of two squares. So difference of two squares, this one factors as x plus 3, x minus 3, doesn't it? So what we can do at this point is set each factor now equal to 0 and solve. Okay, so I'm going to say either x plus 3 must be 0 or x minus 3 is equal to 0, giving me my two final solutions of positive 3 or negative 3. All right, cool deal, everybody. So this last problem was really interesting because I had to set it equal to 0 because it wasn't set equal to 0 in the beginning. And then I had to kind of undo the factorization that they had provided and combine like terms and then factor all over again. So this one was really interesting. All right, I hope you learned about the principle of zero products, and how to solve quadratic equations by factoring. Catch you later.